3.10 A. In a meter bridge, say figure, the balance point is found to be at 39.5 centimeter from the end A, with resistor Y is of 12.5 ohm. Determine the resistance of X. Why are the connections between resistor in a Western bridge or meter bridge made of thick copper strips? Then B. Determine the balance point of the bridge above if X and Y are interchanged. C. What happens if the galvanometer and cell are interchanged at the balance point of the bridge? Would the galvanometer show any current? Now see here. The balancing point initially you are getting at length L1, that is 39.5 centimeter. So at that time your L2, which is 100 minus L1, so that is 100 minus 39.5 centimeter. So that is 60.5 centimeter. At that time resistance Y, that is 12.5, and what is X that you want to calculate. Now here see in this circuit, actually consider this R as X and S as Y. Okay, so X upon Y, that is equal to L1 by L2. So X equal to L1 by L2 into Y. L1, that is 39.5 upon L2, that is 60.5, Y, that is 12.5. So you will get X, that is equal to 8.16 ohm. Now if X and Y are interchanged, then Y by X that we can write equal to L1 dash upon L2 dash. But this L2 dash you can write 100 minus L1 dash. Now Y, that is 12.5, X we already calculated 8.16. Now L1 dash upon 100 minus L1 dash equal to 12.5 upon 8.16. From this one you can calculate L1 dash also. Means after interchanging X and Y, you will get the balance point at L1 dash. You can calculate it from this one. Now here it is asked you, why are the connections between resistors in a Western bridge or meter bridge made of thick copper strips? These are the thick copper strips. Because if the copper strips are thick one, then their resistances will be negligible one. So it will not affect the balancing point. Then in question C, it is asked what happens if the galvanometer and cell are interchanged at the balance point of the bridge. It doesn't make any difference to the balance point because you have to connect between two terminal, the galvanometer, and between another two terminal which are diagonally opposite. In theory we discuss this thing, the battery. So if we interchange, then also the balancing condition that will remain the same one. So there will be no change in the null position or balancing position. So if the balancing position remains the same one, means the bridge remains balanced one, it implies that through the galvanometer no current will flow. Clear to all of you?